Following on from the previous video, we wanted to investigate a scenario where this here is a negative number, and then we use the quotient rule here. So we started out with this. We would reimagine this thing here as this thing here, and then from here we use the quotient rule here to get to this stage here. So we differentiate this by using the quotient rule here, and then it then gave us this, and then it's blah 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 all the way down here. And when we get to down here, we notice that this thing here is, this thing here is really, we would then imagine it as x to the power of minus n here. And then by us visualizing it like this, we can see that if you want to differentiate this whole thing here, then this thing here gets moved down to here, and then the bubble itself here gets minus by 1. So the bubble itself here gets minus by 1. We've seen that. So what I'm trying to say is that in you see, we had to use the quotient rule. We cannot use the product rule, by the way. So suppose you wanted to investigate this here. If you want to use a product rule, you would have to imagine this thing here as 1 times that thing here. So to use a product rule here, you've got to differentiate this, leave this the same, and then leave this the same, differentiate this here. So if you try to use, my point is that we had to use the quotient rule here to investigate, to answer our question. We cannot use a product rule. If we use a product rule, this is what's going to happen. Differentiate this, leave this the same. So differentiate this thing here, that will be 0, and then leave this the same. This will be x to the power of minus n, and then plus, and then leave this the same. So that would be 1, and then differentiate this. You see, when you come to differentiate this, we don't know how to do this. Differentiate a negative number. In the past we've just accepted that you move it down here, but we are trying to investigate a scenario where we have to differentiate x to the power of a negative here. You see, well, you cannot use the product rule to prove this, because we don't know how to differentiate a case where x is a negative number. You see, for us to try and understand how we differentiate this, we had to use the quotient rule. You see, this is what's going to happen if you use a product rule. You come to a stage where you have to try to differentiate this thing here, but we don't know how to differentiate this thing here. We know how to differentiate by using the binomial theorem. We know how to differentiate it when it's a positive number, but we don't know how to use we don't know how to differentiate it when it's a negative. You see, by looking, let's scroll back to here. By using the quotient rule here, you see the quotient rule gets around the fact that you don't have to differentiate a negative number. Watch this negative number. By us, well, so at the moment here, look at this n here. It gets turned to a positive n. So when you come to differentiate this thing here, you see this bit here is you differentiating this. You see, the quotient rule allows us to differentiate a positive n here. That's here we can differentiate a positive because the binomial expansion allows us to differentiate a positive number. But using the product rule, you will come to a stage where you have to try and differentiate a negative. You can't do that. That's why we're forced to use the quotient rule here, because the quotient rule allows us to differentiate a positive n here. You see, this bit here allows us to, well, yeah. So here we're differentiating a positive number here. Don't use the product rule. Use the quotient rule. The quotient rule allows you to, well, we had to use the quotient rule. Okay.